good everyone? You're welcome back to the channel Learn Maths. Today we are going to be looking at implicit differentiation, right? The topic of discussion today is going to be implicit differentiation. Now what sets this kind of differentiation aside from the normal one we have been used to, that's explicit differentiation, is the fact that we have variables mixed up in a given function, right? Now take a look at this function. We have 4xy, right, plus 3y minus 5x squared equal to 2, right? Now if you look closely at this function, you observe that we have 4x. Okay, we have x and y being mixed up, right? We don't have a kind of situation whereby x is on one side and y is on the other side of the equation, something like this: y equal to 2x squared, right? Now for this function, we have y on the left hand side and x on the right hand side, right? But for this other function, we have x and y on the left hand side. If you collect this, no matter how you tend to arrange them, they just get mixed up, right? You have x and y variables being mixed up. There's no way you can keep one on this side and the other on this side, right? Okay, so whenever you're trying to differentiate these kind of functions, you're going to apply implicit differentiation, right? Applying explicit differentiation, which we are all used to, you differentiate this kind of function, but for this kind of functions you use implicit differentiation. Now take note of this: whenever you're differentiating in implicit differentiation, here we're also going to be differentiating y, right? And whenever you differentiate y, you should make sure you add the y dx to the differential of y, right? For instance, this middle term here now, right, if I'm going to differentiate this, it will be 3, right? That's the differential of 3y is going to be 3, but I will attach dy dx to it. Okay, let's just proceed. We're going to find dy dx for this function using implicit differentiation, right? We're going to find dy dx. Now we have 4xy, 3y minus 5x squared equal to 2. I'm going to factor out the 4 being the constant here. We're going to factor out 4. Then we apply product rule to differentiate x and y. This is a product of x and y, right? Now applying product rule, we're going to differentiate x and multiply with y, then add that to the differential of y, multiply with x, right? Now if you differentiate x, you're going to get 1, right? You multiply that 1 with y, plus you differentiate y, you're going to get 1, right? You differentiate y, you're going to get 1. But like I said, whenever you differentiate y, the variable y, you have to attach dy dx to its differential, right? So the differential of y normally should be 1, but then we attach dy dx to that differential, right? Then you multiply that with x, right? This product rule. You differentiate x, you multiply with y. You differentiate y, you multiply with x, right? Alright, so that's for this first term. Let's look at the second term. We have 3y there. Now the power of y happens to be 1, right? So if you differentiate this, you're going to get just 3, right? That's 1 times 3, that's 3, right? Then 1 minus 1, that's 0. So we are just left with 3. But remember, we differentiated y, right? So we're going to attach dy dx to it. Now that's for the middle term, or the second term rather. Let's move to the third term. Now this is negative, right? And we're differentiating 5x squared. That's going to be 10x, right? That's going to be 10x equal to, we have 2 on the other side of the equation. Now if we differentiate 2, which is a constant, we're going to get 0, right? Now I hope you understand the procedures we just took to arrive at this point. Now whenever you differentiate y, you attach dy dx to it. Now let's take a look at this explicit differentiation briefly before we continue with this implicit, right? Now you observe that the differential of this is actually 4x, right? But we don't just say 4x, we actually differentiate this y here. If you have to find dy dx for this explicit function, you're in some way, like somehow we're actually carrying out implicit differentiation, because we're also differentiating this y here. The differential of y is 1, right? Then you always attach dy dx whenever you differentiate y. That's why we have that dy dx is going to be equal to 4x, because we differentiated the left hand side, we also differentiate the right hand side, right? Differentiating the left hand side, we got dy dx. Differentiating the right hand side, we got 4x, right? So that's actually implicit differentiation there. So let's proceed. Let's continue with what the operation we're carrying out here. Now I'm going to open this bracket with the term 4, the constant 4, right? So this is going to be 4y, right? 4y. If you multiply 4 with 1y, that's 4y, right? Plus 4 dy dx multiplying x. Okay, you can rearrange this as 4x dy dx, right? Rearrange this as 4x dy dx plus 3 dy dx minus 10 equal to 0. Now after opening this bracket, the next step to take is to collect like terms, right? Now like terms are, okay, the like terms we're going to be collecting here, I'm going to take the ones with dy dx, the terms with dy dx attached to them, I'm going to keep them on the left hand side, right? Then those terms without, okay, this 10x, this 10x, right? Then those terms without dy dx, I'll keep them on the right hand side, right? So I'm going to have 4x, this is 4x, right? 4x dy dx plus 3 dy dx equal to, now this negative 10x, we're going to send over the equal to sign, it becomes positive 10x, right? Then this positive 4y will send over the equal to sign and it becomes negative 4y, right? Now the next step we're going to carry out is to factor out dy dx from the left hand side, right? Since both terms have dy dx attached to them, we're going to factor out dy dx. Now if you factor out dy dx from this first term, you'll be left with 4x, right? Factor out dy dx from this term, you'll be left with 3, right? Now this is going to be equal to 10x minus 4y, right? Finally, to get dy dx, we are going to divide both sides, both the left and right. Divide both sides with 4x plus 3. So we're going to be left with dy dx on the left hand side. Then on the right hand side, we have 10x minus 4y divided by 4x plus 3. And this will be the answer for dy dx, right? Okay, so we're going to take another example. And this example, we're going to just try something out. Let's try differentiating this function. Y square equal to 4x square, 4x square. Now I'm going to see if I can actually differentiate this function using implicit and explicit differentiation, right? I'm going to start with explicit differentiation, right? Now to differentiate this explicitly, I'm going to have to keep y on one side and x on one side, right? So let me rearrange this equation as y equal to square root of 4x squared. The reason why I took the square root of the right hand side was because I want y to be alone on the left hand side, right? So this is going to turn out to be y equal to 2x, since the square root of 4 is 2 and the square root of x squared is x, right? So this is a simple function, y equal to 2x, right? We can just go straight to differentiating this and getting 2, right? The differential of 2x is 2, the differential of y is 1, then you attach dy dx, okay? Just say dy dx equal to 2. So using explicit differentiation, this is what we got. We got dy dx to be equal to 2. Now let's try using implicit differentiation here, as I'm going to be differentiating both x and y, right? You can decide to mix this up as y square minus 4x square equal to 0, right? You can decide to go this way, but I'm just going to go straight to differentiating both terms as they are, right? So the differential of y square is going to be 2y, right? 2y. Then remember to always attach your dy dx whenever you differentiate y, right? Now on this other side we have 4x squared, so the differential of 4x squared is going to be 8x, right? 8x. Now I'm going to divide both sides by 2y, this 2y here. The reason I'm doing so is because I want dy dx to be alone on the left hand side, right? So we're going to arrive at 8x over 2y, right? We divide both sides by 2y. This is what you get. Now this is 8, this is 2, right? They're going to cancel out, leaving us with 4. So dy dx is going to be equal to 4x over y. Now remember, when we simplify this function, we got y to be 2x, right? You can see the value of y here. Y is actually 2x. 2x. So I'm going to substitute this value for y into this differential. So at the end of the day, we're going to have that dy dx is equal to 4x over, what's this? 2x, right? This y here is 2x. So x is going to cancel out x, then 4 divided by 2 is going to be 2, right? That's dy dx, 2. Implicit, explicit, same answer, right? Alright, we're going to take one last example on implicit differentiation for the sake of understanding, right? Let's take one last example, and this is going to be 2y. Let's try 2y raised to power 3 plus 4x squared. Okay, let's attach y to that, minus 8x plus 4, okay, equal to 0. Let's try differentiating this using implicit differentiation, right? Now the first term here happens to be 2y cubed, right? So differentiating this, we're going to have 6y squared, right? 6y squared. And remember, we differentiated y, right? So we're going to attach dy dx to that differential because we differentiated y. Alright, so the next term is 4x squared y. I'm going to factor out 4, the constant there, then apply product rule to differentiate x squared and y, right? This is product. We're going to apply product rule here. So I will differentiate x squared, multiply with y, then differentiate y, multiply with x squared, right? So the differential of x squared is going to be 2x, right? The differential of x squared, 2x. You multiply that with y, plus the differential of y now happens to be 1, right? 1. Differentiate y, you get 1. But as usual, we attach dy dx whenever we differentiate y, right? Now you multiply this with x squared, right? That's product rule. You differentiate the first term, multiply with the next term, right? Plus differentiate the other term, multiply with the first term, right? That's just product rule. There's a video on lemmas about differentiation using product rule, so you can actually check out that video, right? So this is going to be all for the second term. Let's move on to this next term, negative 8x. Let's differentiate this term. Now this is going to be 8. There is no y attached to it, so there is no need to attach the y dx. Just go straight to differentiating 8x, negative 8x, and you get negative 8, right? Now this 4 is a constant, right? It's a number without variable, so it's a constant. And this differential is going to be 0. Okay, we're going to put down 0 there. Everything is equal to 0, right? So next step we take, we open these brackets, right? Let's open those brackets. This 6y squared dy dx plus, now let's open these brackets, 4 times 2, that's going to be 8xy, right? 8xy plus this 4 times x squared, okay, that's going to be 4x squared. Of course, we have our dy dx attached to it. Right now the bracket is opened, we have negative 8 here, or this insignificant, equal to 0, right? Now the next step we're going to take is collect like terms, right? The terms with dy dx keep on the left hand side, the ones without dy dx is sent to the right hand side, right? So this is going to be 6y squared dy dx and 4x squared dy dx. Now this is going to be equal to, okay, I'm sending negative 8 over the equal to sign, it becomes positive 8, right? You send positive 8xy over the equal to sign, it becomes negative 8xy, right? Next, we're going to factor out dy dx from the left hand side, right? So factoring out dy dx, this is what we're going to have. We're going to have dy dx outside the bracket, then in the bracket we're going to have 6y squared plus 4x squared, right? Now all this is going to be equal to 8 minus 8xy, right? Finally, okay, that's going to be the final step. Let's see. We're going to divide both sides by 6y squared plus 4x squared. 6y squared plus 4x squared, right? Divide both sides by that. This cancels this. So dy dx is finally going to be equal to 8 minus 8xy over 6y squared plus 4x squared, right? Okay, we can actually factor out 2. Now this would have been the final answer. Let's factor out 2 from both the numerator and denominator and just simplify the answer. So dy dx is going to be equal to, okay, it will be 4 minus 4xy, right? Then from the denominator we factor out 2, this will be 3y squared, right? Plus 2x squared. Okay, now this 2 cancels 2. And finally, we have dy dx equal to 4 minus 4xy 3y squared plus 2x squared, and that's the answer. Alright, I hope you enjoyed the video. Do well to like this video, share this video, subscribe to this channel, just do what's right, and I'll see you in the next video. Bye.